So in this video, I'm going to be starting off with something kind of easy. I'm going to be proving the derivative sum rule. And what the derivative sum rule says is basically the derivative of a sum is the sum of their derivatives. So if I have something like 3x squared plus, make that a better plus 2x plus 1, right? If I have something like this, the derivative of this, if I want to say d over dx, which is just the derivative operator, right? If I want to take the derivative of this, what it's going to be is the derivative of each individual term here. And the sum of all of those will be the derivative of the entire the entire thing here. So the first one, 3x squared, that's going to be 6x using the power rule. The second one's going to be 2. And the last one's going to be 0. So that's going to just be 6x plus 2. Right, so that's kind of all there is to that. Now, if I want to prove this, it's not too hard to prove. It's not too rigorous. What you do is you write your difference quotient like you always do. And so I'm just gonna write that over here. Delta x approaching 0. And then what we're gonna have is, I'll say like f of x and g of x. And what I mean by that is, let's say one term is f of x and this term is g of x. And you could do as many terms as you want. It'll work anyway. But just for the sake of it, let's say like our first term here, f of x is 3x squared and g of x is 2x. And so what we're going to write over here is f of x plus delta x. And then we're going to have plus g of x plus delta x. I'm going to put that in brackets. And then what we're going to have, I'm going to extend this, we're going to have minus bracket f of x plus g of x. Okay, so this is just the difference quotient over delta x. So this is just the difference quotient. There's nothing new here. So we haven't really done anything yet. This is kind of just rewriting it in the form of the difference quotient, which is the derivative, right? So what I'm going to do now is I'm going to say this is equal to, and I'm going to rewrite the limit as delta x approaches 0. And now what I'm going to do is I'm going to split this into two pieces. So what I'm going to do, I'm going to make two limits here. I'm going to say f of x plus delta x, and then minus, and you have a bracket here, forgot that. Then both of these are going to be negative, right? So I'm going to take one of these, and I'm going to say negative or minus f of x, right? And that over delta x. And then what I'm going to do, is I'm going to take the other term here, g of x, or not other term, other function here, we're going to have g of x, and I'm going to split this again. And what I'm going to say now is plus, or well, I'm going to say plus, and then make a new limit here, and then say delta x is approaching 0. And I'm going to say, over here, I'm going to say our new function here, or our g of x here, I'm going to put that in, and we're going to have g of x plus delta x, and then minus g of x, and then all of that over delta x as well. So all I did here was I split the original difference quotient into two pieces. And I can do this because the sum of a limit is the limit of their sums. That's another rule. I'm not going to prove that right now. it's pretty intuitive. You don't really need a proof to understand it. You can kind of reason why that would be true, because you're not really changing anything here. But anyways, the reason that we're saying plus here is, like I said, we're splitting into two pieces, right? And this negative right here is making both of these in here negative, right? So negative f of x minus g of x. So that's how both of these can be negative here. And then what this means here, if you recognize this, this is just the derivative of f of x. So this will be equal to, make that better, this will be equal to d over dx of f of x, right? It's the definition of a derivative. And then we're going to have plus d over dx of g of x, right? And that's not too bad. That's really all there is to it. It's a pretty basic rule. You'll use a lot, especially in polynomials. But this allows you, and you could make this as long as you want. You could make this have, I don't know, like h of x or whatever. You can have as many terms of this as you want. It can keep going, right? There's no limit because you just apply the exact same idea as many times as you want. But that's the idea. That's the proof of it. So if you want to use this, you can. It's just one tool to add. But yeah, this is something that you're going to be using a lot in derivatives. So you really need to have this down. I wouldn't say memorize it, but just know what it is and be able to kind of think of it intuitively, and understand what it means when you're saying the derivative of a sum is the sum of a derivative. Because you have here, we started with a derivative of a sum, and we ended with a sum of derivatives. We have two derivatives here. So that's what that means when I say that. It may be kind of tricky to understand when I just flat out saying you don't understand what I'm talking about, but once you learn it, it makes sense. But that's gonna be, actually, I'll make another example just to kind of nail this down here. So if I say, let's say I want to find the derivative, and I'll write in a different notation this time, just so other people can understand. So f prime of x. Same thing as derivative. Same thing as d over dx. So let's say we want the f prime of x of, I don't know, 4x plus 2 plus 2x plus 1. Now, I mean, this doesn't really, I mean, you can just add these terms here, I guess, but let's just not, and let's see what happens here. So let's keep these two things separate, and then we'll come back and add them, see if we get a difference here. Right, so first off, we're going to be taking the derivative of each individual term here. So we have 4x, 2x, and 1. So the derivative of 4x is 4, the derivative of 2x is 2, and the derivative of 1 is 0, because the derivative of any constant is 0. So then, okay, that came out a little weird there, so I'm just gonna, you don't get it. But 4 plus 2, right, that's 6. So that would be our derivative of that. Now let's say I want to combine these two and say 6x plus 1. Right, so here we have two terms, it's just gonna be 6, and we have 0. Right, so we get the same thing here. So it doesn't really matter how you approach it. But just practice with it, use it a lot, do lots of examples with it, do lots of quizzes. If you want to watch other videos on it, I would say this is probably the easiest rule you can learn, and it's definitely the first one you should, because like I said, you use it all the time moving forward. Like every instance, it's going to be used a lot. So that's the derivative sum rule. So I hope you understood that well and you continue to learn it.